Good afternoon, everyone. So I'm standing between you and your favorite cocktail in about an hour from now. Try and get you out of here quickly. But today is a very special day. I finally agreed with my wife to gel my hair and wear a collared shirt. So thank you very much. I guess I don't have a future in stand-up comedy, so we'll get into the technical stuff now. The last two gentlemen who are up here, I mean, who would have thought, right? Ty stood up here talking about MIPS, adopting RISC-V. We never thought that day we would see it, but it's here. And that just talks to the strength of the RISC-V revolution. And Mark stood up here. But both of them mentioned one thing that was common and is very relevant. You can't get away from FPGAs. Okay? So we're here to talk about mid-range FPGAs. Microchip does have, as one of its largest divisions, an FPGA line, which basically services the low-end FPGA market and the mid-range FPGA market. And I'm here to talk about that. This talk is not just about an announcement. It's about a series of happenings that has taken place. And it's not only a look for the future, but also a retrospective look. I put a profound quote up here, which I use for many, many purposes. I don't know how many of you know Jose Rizal, but he was a Filipino nationalist, a polymath, and a writer who stuck it to the Spanish colonialists, middle of the 19th century to the end of the 19th century. And basically, he who does not know how to look back at where he came from will never get to his destination. And I think this talk today is apt, and it follows this ethos. My name is Shakeel Peera, and I am the Vice President of Marketing for the Microchip FPGA business unit, and I manage a couple of things, including marketing and strategy. Now, this is a timeline not based on a logarithmic scale, just I messed around with it so I could get all the graphics to fit. But I wanted to take a retrospective look as to how we got here today, and it is very telling. Microchip claims to be a pioneer in the RISC-V FPGA revolution. I'm going to tell you a little bit of a story about it that will explain where we are going from here. Okay? Any revolution has many chapters. The first chapter is a nascent chapter. This is when the little whisperings take place. A change needs to be made in cafes, in our case, in a sushi bar. And basically, this nascent conversations took place with luminaries from Berkeley. And our own representative on the board of directors, Ted Spears. Can you raise your hand, please? So Ted basically was exploring this at an academic level with Berkeley and the students and the professors who came out of this, who started the RISC-V journey for the entire industry. We attended our first workshops. We met with people at Berkeley. And we basically, as an organization at that time, when RISC-V was still in its infancy, it wasn't even born yet, it was just a gleam in someone's eyes, we became RISC-V aware. I did not know about this. And Ted was working this as a side project with Tim Moran, who is now a fellow at Microchip as well. The second stage of any revolution is the struggle, okay? And in our case, we actually had an incident called the fight that took place at the Hyatt House here on North First Street. There were bottles broken. As with any revolution, there is a fight that involves alcohol. So this was one of those events. And I was one of the doubters. And here I am standing today talking about this, right? Just like MIPS came and talked about RISC-V, I was actually one of the doubters. We had a whole portfolio of FPGAs that had ARM on it. We had a customer come in, and basically the conversation started like that, right? There was a seed. A client came in and said, look, we don't like your FPGA with this processor in it, unnamed processor, okay? We want a custom cache. And guess what happens when you ask for a custom cache in a proprietary ISA that has a fixed off-the-shelf product? You're not going to get one unless you buy an architectural license. That was a seed of the struggle. that took place. And we had to choose at that time, as a management team, to choose a side, and we chose a side. We started off with a soft processor that was synthesizable, that could go into any FPGA, as we started exploring what we do with our future products. We started off with the first self-funded ecosystem called the Mi-5 ecosystem, Mi-5, right? With 5 partners that could give us at least a foundational capability in terms of RTOS. And then we started exploring with our partners. One of our first partners was the people we were talking to in the cafes and in the sushi bars, right? It was Sci-5. Basically what we did, we paired an FPGA and Sci-5 RISC-V ASIC together to basically have a proof of concept that these two things, these two entities could work together and bring about what is the third chapter of our journey in any revolution. And this was basically announcing to the world that an upstart like us, who has a minority market share in the FPGA industry, is going to attempt to shake up the history of compute, okay? And what we did was we announced the first hardened microprocessor subsystem architecture in an FPGA. We did not know where the journey was going to take us, but we had needs. We had needs that needed innovation. We had needs that required out-of-the-box thinking, and that could only be served by an open ISA. And RISC-V was the answer, okay? About a year later, we shipped the PolarFire SoC samples, which was the FPGA with a hardened MSS. Now, the architecture that I was talking about was announced at the inaugural RISC-V Summit in 2018 at the Santa Clara Convention Center. We had our first Mi-5 Summit with our own ecosystem. Today, you see, for example, and I'll be very open about it, Intel has Pathfinder for their foundry services. We actually did this many, many years ago. And we did so in a manner that basically tried to foster an ecosystem for the whole community. Earlier this year, in about June or July, we were the first FPGA vendor in the world that shipped out production families of the PolarFire SoC with the hardened RISC-V MSS. Okay? Today, the Mi-5 ecosystem, moving forward, has 62 partners, basically representing about 90+% of the operating system frameworks that people need to start off a project. Okay, and I'm going to show you that as well. And then finally, at the end of the talk, we're going to talk about the future as well. But I wanted to make sure that the audience here understood what it meant for this journey to take place. This is a series of announcements, and many of you may not even know, sitting here in the audience, what Microchip FPGAs brought to the table in terms of this revolution. So I wanted to make sure that this retrospective look was had. Okay? With any successful product, and PolarFire, the PolarFire platform for Microchip, is the most successful FPGA platform that we ever launched. It has enabled us to grow in ways that we never imagined. We're about a 36-year-old company, and we are growing in leaps and bounds since we announced PolarFire. But basically, what happened was there was a system challenge in the industry with programmable logic having to address what is now known as edge compute. And you're going to hear about this over and over again. It's become so cliched. Edge compute, edge compute, edge compute. But you can't talk about edge compute without the need for FPGAs. There was artificial intelligence, machine learning, edge compute, embedded vision. These are all things that need a compute horsepower, but need this at a very thermally efficient manner. Aerospace and defense, and then transporting data out through wireline and wireless infrastructure. So, the common things that we saw, themes that we saw clients asking for, are how do you get an FPGA that basically adheres to thermal constraints of anything on the edge, with minimal power budgets, with safety and security, but there's no guards and gates guarding these systems like you would in a central office, and with flexible compute requirements. And that's how we came out with PolarFire FPGA. That gave us the foundation for low power. It was the most power-efficient mid-range, and still is power-efficient FPGA in the market, bar none, no matter what you hear about in the industry. the most secure FPGA. These FPGAs secure the national assets and strategic assets of the United States, okay? And highest reliability. Anything that flies, you step on a plane today when you go back home, there's going to be a Microchip FPGA on it. That is the only way that these planes fly. And then on top of that, we wanted something that basically where we could port Linux, could port bare metal, and a combination of both for asymmetric processing. And we came out with PolarFire SoC, and this RISC-V ISA allowed us to do this. Okay? Freedom to innovate. This is what RISC-V allowed us to do, where we could not get a solution anywhere else in the market. Today, we are known for these three things. Okay? Most power-efficient FPGAs, bar none. Okay? Exceptional reliability, we're completely SU immune, to the point where NASA JPL has chosen us for high-performance space compute, which you guys may have seen in terms of a press release. And military-grade security. We don't only have commercial-grade security that most chips have. We protect the assets of the United States, and we are bringing that kind of security to the commercial marketplace. Okay? And it has allowed us to expand the PolarFire family into a PolarFire FPGA, a PolarFire with a hardened RISC-V processor in it, as well as a red-tolerant PolarFire that flies out into space. You guys have heard of Artemis, correct? It's going to be an RT FPGA on it. Okay? So anything that flies, as we fly out of the solar system, we will be flying with it. So what is this freedom to innovate, right? And I'm going to quickly go through this. When we were looking, again, to solve those edge compute problems, we knew that we needed a processor cluster that basically could have ported on it both Linux OS as was real-time. Solution did not exist unless you paid an architecture license. It needed to be portable into a thermal and power-constrained system. It had to be securely connected into an IoT system that had cybersecurity threats. And it had to be in a high reliability, safety-critical system as well. The trigger that I was talking about, the seed, the original seed, when we talked about the original seed, was the configurable cache. And this was a big trigger point for us. We needed a 2 meg cache. What was available to us was only a 1 meg cache. But for us to be able to independently run software contexts on multiple processor subsystems, we had to have a 2 meg L2 cache. And this allowed us to do it. So with our partner Sci5, as well as our ecosystem partners who are gathered around you today, we came out with this. Okay? We don't know if it was a brave or foolish decision at that point. We tend to think at this point in the history, it was a brave decision. Here's one of the things it enabled, right? When you talk about independent software context on multiple cores, it allowed us to do this. For example, with Industrial 4.0, you could port real-time functions like a drive, motor control drive, networking, sensor interfacing, while putting Linux functions independently on one of the other cores, HMI, a security function, OpenPTP, or over-the-air updates. Okay? So any industrial system that you see today, industrial robotics, industrial automation, will have both these functions. But this gives them the fungibility to do this in any way or manner that you want. That is, by definition, what an FPGA should do. Okay? The other thing is, you usually learn in politics that money is power. In the FPGA world, power is money. These FPGAs have come with exceptional compute and thermal efficiency. On the left-hand side, you will see a graph that basically shows you that by the time our nearest competitor gets to any type of starting compute, we already at 6,500 core marks. So imagine what this means in terms of core marks per dollar. Okay? We are already doing something when the competition is not even on, or is struggling to get on, and leaking current. On the right-hand side is actually an actual customer demonstration. We went out to a client and did a demo for a machine learning algorithm. This client, who happens to be in Australia, put their finger on the FPGA, and they basically told us to our face that we were lying because the FPGA was not working. Because why? It was cold. Hence the name PolarFire, right? And that's the picture on the left-hand side. And then they brought out the competitor system and said, put your hand on this, and you couldn't put your hand or your finger on it for more than 30 seconds. You would burn yourself. this is what it allows. It allows you to basically throw out heat sinks, it allows you to throw out fans, and our study basically shows that you save about $1.50 per watt removing fans and heat sinks. Okay? There were journalists walking around in the inaugural 2018 summit. And the main refrain was, we'll see. This is exciting. There was a Star Wars theme going on, Rebels and stuff like that. But the common refrain was, we'll see. We'll see. And the main barrier was ecosystem, right? The ecosystem part of it was a difficult conversation to have. Today, as a pioneer in the FPGA ecosystem, we can safely say when it comes to bare metal SDKs, commercially available Linux OS frameworks, as well as RTOS, we have enough partners going from 5 to 62. And by the way, there was an announcement that ran from Siemens today for SOCO. This is an OS, commercially available Linux OS system that went out today. I think it'll be number 63, if I'm not mistaken, that we can cover 90+% of anyone wanting to start off a development with a commercial open source RTOS or OS or bare metal. Okay? And we saw strong adoption in SWaP-C sensitive mid-range FPGAs. And this was basically around imaging. When you talk about edge compute today, what are you talking about? You're talking about less about the mini data centers and more about the stuff that you have in your hand you're taking pictures with. These are the endpoints. A lot of imaging, image processing, artificial intelligence, machine learning is going on. And in each of these categories, we have been extremely strong. It has driven our growth from strength to strength to strength. And I like to, my staff always makes fun of me because I carry this trophy cabinet around everywhere I go. I like to say, like Jeep, we're the most awarded FPGA on the planet over the past 35 years. 10 for 10. So this has allowed us, our partnership with the RISC-V international ecosystem partners and the Open ISA has allowed us to innovate to the point where we feel very confident that we are now in the execute and scale stage, as opposed to the nascent and the fight stage. We are now onto the next stage. So we're getting ready for more. You guys ready? What comes after PolarFire? Anyone venture to guess? PolarFire 2. Okay? Now, we are trying to solve specific problems on the edge, right? We talked about this. Artificial intelligence, machine learning, IoT, wireless and wireline infrastructure, embedded vision. We are very well known for aerospace and defense and power efficiency. So the engineering team, this did not involve drinks, by the way. But basically, we told them that, look, we want to go from here on the left-hand side, which is what PolarFire offered, moderate capabilities on artificial intelligence, machine learning, about 40 gig of fabric performance, up to 4K video support. This was back in 2016, remember. We wanted to maintain SCU immunity for aerospace and defense, military-grade anti-tamper security. And by the way, you need to do all of this, double everything, and in some cases, make processing 15 times more, but maintain the same power. Okay? So there was interesting conversations, but they delivered. Today, we are announcing that we are committed to the RISC-V ISA, second time in a row. We saw what it could do with us with PolarFire. With PolarFire 2, we will now double our power efficiency again. What we are known for with PolarFire is that we are 2x more efficient than any platform, FPGA, mid-range FPGA platform that's out there. With PolarFire 2, we're going to double that efficiency again. So 2, 2, 2. Very easy to remember, very easy to write about. With military-grade anti-tamper, cybersecurity, and configuration SCU immunity, all built in. You will not see an FPGA on the planet that does all of these. By the way, when you start combining all the RISC-V compute elements that we are including in this FPGA, the number of TOP per second is going up by 15x. From PolarFire 1 is already best in class. Now just imagine making the compute horsepower 15x more at the same power. It is unprecedented. It's something that has not been seen in the industry before. So we are very excited about that, and I hope you guys are as well. Okay. PolarFire 2 extends our mid-range FPGA leadership. The 222 is in effect. We're immune to SCU upsets with infinite reprogrammability. This is a trick that no one else has been able to do. But this is a sneak peek. We are not going to be revealing any more details as to how we did it or what we are going to do. Today, we are gathered here to talk about the why, not the what. The what will come later, and I'll tell you when we're going to talk about it. And next-gen military-grade security that is resistant to emerging cyber and physical security threats. Guys, you guys can go read about what those are, but they're going to be resistant to all of them. Plus, you guys saw the NASA JPL announcement about high-performance space computing, and remarkably, they went with the RISC-V as well. Okay? So what is going to carry mankind to the moon and beyond will have high-performance spaceflight computing powered by RISC-V. Our FPGA is going to be compatible with this Microchip HPSC that will be released by another business unit. So these two in conjunction will work together to provide HPSC, complete HPSC ecosystem for flight compute. Do not miss a keynote that will be given by NASA JPL at this very conference. Very, very exciting. Okay? Now, the gentleman from XMOS, Mark, was here, up here. You guys remember what he said about FPGAs? We take everything that's said about FPGAs, good, bad, or ugly, we take it into consideration. The gentleman here said that, well, FPGAs are expensive. Okay? Debatable. But also said that FPGAs are hard to use for embedded system designers. They're hard to use for the computer engineers because FPGAs are custom logic. Completely true. Okay? And you see what is going on in the FPGA industry to basically try and bridge the gap between the capabilities, the innate capabilities of FPGA. No one comes up here and says, you know what, FPGAs are not good at doing this. It's always, FPGAs are very good at doing this, but they're expensive. So now this barrier for these computer algorithm designers who are going to be designing the next generation of AI, ML, IoT algorithms, this is what they desire. They love FPGAs. They don't want to understand it. Okay? Understood. They don't go to school to study custom logic, but to design algorithms. The idea behind FPGAs is they're very good at doing this. Fungible, doing multiple things at the same time because they're reprogrammable, but they're averse to people who design with C, C++. Okay? So when you guys go around and talk to our people in the booth, basically you will see a series of tools that we're bringing out, and all the other FPGA guys are trying to do the same thing, except for one. Basically trying and abstracting the FPGA physical design away from the computer engineer. And they can basically write their algorithm in C, C++, and do so fungibly, having basically executed on solutions, fungible solutions, with one FPGA platform. Okay? So the other thing that we are announcing is a new design suite that will go with PolarFire 2. Okay? This basically will have faster design and debug, will allow for efficient FPGA use, fabric use, computer hardware abstraction. This is the most important thing in this conference for people to understand this. Because most of the people that you're going to be talking to will be designing in C, C++, and system integration. Okay? This is going to be extensible. It will allow this tool to work with other tools in the industry. It will allow, most importantly for this conference, hardware software co-design. Okay? So basically you can design in HDL as well as C++ and do them in an integrated fashion inside of one tool, allowing for significant ease of use and productivity gains for the people who are going to be at the conference tomorrow. Okay? They'll have two things. One is a traditional FPGA design. They'll have the mandatory, I was talking to Brian Moyer, who is actually an ex-Actel employee. Basically, we were discussing the same thing. FPGAs are the biggest barrier to entry. Tools are the biggest barrier to entry. And what we try to do every generation is try to lower the barrier of entry. So if they're coming from one of our competitors, they find it easy to use our tools. So those are mandatory. But the system designer is where the system abstraction will take place. Hardware abstraction will take place so that the computer engineer can basically design using nominal FPGA tools. Okay? And one of the reasons why I ran long was so that I won't have to take any questions. So if you guys do have any questions, come and visit us in the booth or tackle me right after the talk. But I will take some questions. I would like you guys to invite you to come to our booth and check out the claims that I've made up here. Come and check out the revolution, okay? Bruce Wire. Bruce, can you raise your hand? Bruce is a corporate VP of the business unit. He will be talking about this journey in less flamboyant terms, but in a lot more academic terms. So he'll be there tomorrow at 11 o'clock in hall number 3. And then don't miss Pete's talk. He is coming from JPL NASA. Basically, he will be talking about why they chose RISC-V for the most challenging computing challenge of our times. Why did they do that? I mean, there are so many other choices out there. Why RISC-V? And it's going to be interesting because you will learn from that why we do this for edge computing as well. Okay? And that'll be on Wednesday. This is a sneak peek. So this is devoid of the what's. The reason why we chose this summit to basically announce this is to make a statement that we are all in with the RISC-V ISA. And not only have we used it for our first generation, but we are so happy with it that we're going to use it for our second generation to basically show the world what is best possible with mid-range FPGAs that they've never seen before. We will announce an official launch on PolarFire 2 and what we're going to do with it at the Mi-5 Summit, which is a Microchip event in the summer of 2023. Okay? But we're more than happy to take questions and give you obfuscated answers about the what's. But that is my talk, and I appreciate your attention today. Any questions? Yeah, I'm over 2 minutes over. So I'm still standing between you and your cocktails. If there's no questions, and if you guys want to come and visit us in the booth or tackle one of those rowdy guys over there and the girls over there, they're all the subject matter experts on this thing, we'll be happy to do so. I really appreciate your time. Thank you very much.